All right, ladies and gentlemen, our notes for the day actually have to do with something rather simple. We're going to talk about the introduction to functions. So, a couple of things that we actually are going to talk about. We're first going to define what a relation is, what a set is, and then we're going to talk about everyone's favorite thing, domain and range. So, a relation is a pairing of input. Might have to zoom in here. Input, so X values and output. So Y values, and it is a set of ordered pairs. Which we know are X and Y. A set is a collection or a group of objects listed in braces. So you'll see these right here. These things right here, the squiggles, those are braces or brackets. What is the domain? So now everyone's favorite thing. The domain is the set of all input or X values. Set of all input X values is the domain. And that's from left to right. So we always look at a graph, farthest left to farthest right, that's going to be our domain, which means the range is the set of all output or Y values and that always goes from bottom to top. Okay, we always start with the smallest smallest number, and we always go from bottom to top or left to right. So let's look at this first example. State the domain and the range of the relation. So one of the things that I am going to do that tends to help me a little bit is I see all of these numbers here. And I'm going to go ahead and use purple because I know that domain, that's my X values. So all of my X values, 1, 1, 4, 4, 9, 9. Those are all my X values. So that means the domain, that's a really bad squiggly line. There we go. The domain is 1, 4, and 9. Yes, I understand that they repeat each other, or they repeat, I should say, but we don't have to put them every single time they repeat. Okay? So if domain is the X values, that means range is the Y values. So -1, 1, -2, +2, -3, +3. So we always start with the lowest number. We always go to the highest number. So we're going to go -3, -2, -1, 1, 2, 3. And there's our range. Okay. Whoa, that was weird. So sketch the graph of the relation x equals y squared and state the domain and the range. Make a table of ordered pairs that satisfy the equation, plot the points. One of the things I think is important to make note of is we have this equation x equals y squared, and right now we actually cannot plug that into the calculator and graph it if we wanted to. So what I would tell you to do is if you have a graphing calculator and you want to see what it looks like, we need to solve for y, which means if we take this x equals y squared, to get y by itself, we have to square root it. So we would think that y equals the square root of x. However, this problem is always trips people up because whenever we take the square root, we need to remember that any negative number is also positive when we square it. So not only is y going to equal the square root of x, y is also going to equal the negative square root of x. So notice the negative's on the outside. Because if you plug this in and look at the table, and I already did this, so let me show you what I get. When x is 0, y is also 0. When x is 1, y is 1. Okay. But when x is 1, y is also negative 1. So that means when x is 4, we get a positive 2. But when x is 4, we also get a negative 2. And then 9, we get 3. 9, we get negative 3. So when I come over here to graph that table, it starts here. 4 is positive 2, negative 2, 9, 3. So this is like awkwardly going to be like right here and right here, I think. Might be more like 2, 4. I see what I did. This is what happens when I record these videos too late. This goes here. 6, 8, 9 goes here. So it's gonna, ooh, that was horrible. So it's gonna look something like this. Okay. So remember our domain. These are our x values. So looking at this graph, we start at 0 and we go to infinity. And I know that this is from left to right. So I know that x has to be greater than or equal to 0. Or another way we could write this, 0 to infinity. Range is the y values, and so this is the lowest value to the highest value. If I keep drawing this graph out and keep zooming out, it's going to continue to go like down and down and down and down and down. So it's going to go from negative infinity, because it's just going to keep going down, to positive infinity, because it's still going to keep going up. So my range is all real numbers, or negative infinity to positive infinity. To save us some time, we're actually just going to skip this next example. We're range, oh hey, to the next page. Okay, so we have example number 4. Kendra tosses a softball into the air with an underhand motion. So I want you to think about a softball being thrown. It's going to be a curve, so we're going to actually end up with a quadratic function. The distance of the ball above her hand is given by that function, h equals 32t minus 16 squared, for t is between 0 and 2, where h is the height of the ball in feet and t is the time in seconds. So we're looking at seconds from 0 to 2. Okay, so construct a table that gives the height of the ball in quarter-second intervals, starting with t equals 0, ending when t equals 2. Okay, so one of the things that we can actually do is put the equation into y equals and look at the table. Okay, so I'm going to write that here. Give me a second. I'm going to write it down. I'm going to pause the video, write it down, so it's just going to magically appear for you guys. Okay, so I went ahead and filled in the table, and then I put some notes there about putting the equation into y equals and use the table to fill in that table. But you'll notice when you do that you don't see 1/2, 3/4, 5/4, 3/2, and all that stuff. That's why I added there in orange. Use the second window, so hit second and then window to change delta table to 1/4. Okay, so that's the change in table. Instead of going up by ones, if you do that, you actually make the table go up by 1/4, and then you can fill in your table. But that graph ends up looking something like this. So we start here, and I'm going to end here at 1. We're at 16. What is that? 3/4. We're at 15. This one we're at 15. Then we have 12 at 1/2, which means at 3/2 we have 12. And at 1/4 we have 7, which means at this one we also have 7. And we'll just go ahead and connect those dots as best as we can. Okay, so looking at this domain, our x values, in this case, happen to be our t values. Okay, so t is between 0 and 2. So t has to be greater than 0, but it has to be less than 2. Range is our height. So use a different color. Go from 0 to 16. So my height has to be between 0 and 16, but it's everything included. That's why I use interval notation. Or we can use 0 is less than or equal to h, which is less than or equal to 16. Okay? Alright, so honestly, I don't know why they didn't start with this, but now we're actually going to define what is a function. A function is where each domain or x value has only one output or y value, so it's only paired with 1. Give me a second to write that down. So what that means is that the x's can only be used one time, but the y's can be used as many times as they want. Okay? So how do you know if a table or a list of points is a function? We know that if we have a list of ordered pairs or a table, the x's cannot repeat. Let's zoom in here. The x's can't repeat. Okay? Absolutely no x's can repeat. If they do repeat, the relation is not a function. Okay, how can you tell if a graph is a function? This is where we use the vertical line test, also known as VLT, to determine if a graph of a relation is a function or not. So how do we use a vertical line test? We literally draw a vertical line through the graph. If any vertical line crosses the graph more than once, it is not a function. If it only crosses or touches the graph one time or once, it is a function. Okay, so let's look at what that looks like. So look at this first example here. If I draw vertical lines straight through this graph, notice it only crosses the black graph one time. Each line only crosses one time, so yes, it's a function. But look at this one over here, very similar to the one we just graphed on the other side. If I draw vertical lines, notice they cross twice. Each one crosses that graph more than once. No, not a function. Okay, you are welcome to do, oh wow, you are welcome to do the examples down here, but I'm not going to save us some time. I apologize for the technical difficulties of this video. The next one will be better, I swear. Okay, let me know if you have any questions.